Assalamu alaikum warahmatullahi wabarakatuh. I am Idris Al-Dailami with matrix number 1622847. I'm really sorry because I couldn't show my face. I face really many difficulties. I tried to install many programs, but I couldn't solve this problem for showing my face because my camera of laptop couldn't work. Uh, Anyway, I will present me and my team this our project car price prediction, and we can see here. I will start with the introduction, and of course, in our life, every person needs a car to transfer from a place to another, and many people cannot purchase a new car, and our project is give the car or predict the proper price for the second hand car, and this can help many people that they want to buy their car, means self car in second hand. And also for example, in our project, it can also help many program application or sites look like modem that help people to sell or buy their products, especially car. And they it our project, it can give them a proper price for a second hand car. And our objectives, we have six objectives. First of all, we will clean the data, and I will explain how why you chose this data for predict car price predicted. And after we clean the database, we have to select the best feature for this model with highest effect on the price, and we need to visualization to do visualization with this data to understand or how can we use the proper model, because visualization we can see the pattern of data and we can choose the a good model. After that, we will do data analysis, of course, by using mini model, like we use linear regression and multiple regression and polynomial multiple regression, and we can see later how can we deal with these models in our project. And the fifth step, of course, we need to understand and build polynomial multiple linear regression algorithm. And the last thing, we have to evaluate and enhance the model if our project need for that. Expected output, we are expecting that our model will be able to predict the car prices with an accuracy of at least 0.65%. If not, we are going to refine our database or analysis approach. This means if our data, if we couldn't get the high accuracy in our data, we need be clean our data, or we try to choose another algorithm. If we reclean or re-choose another algorithm for our data, it may be increase our accuracy. For data exploratory analysis and visualization, if we can see the our data, there is a lot of columns or variables in our data, and I will explain it in depth in the next slide. We can see, checking the correlation between variables and response, and only integer variables are selected 16 variables that we need it in our project to do the algorithm linear regression, multiple regression, and polynomial multiple regression in these variables, 16 variables. We can see that our database is 201 observation and 29 variables, and we can see the type of variables is different between integer and factors and number. And this is the variables. We can see here the sampling and normalized loss, and we can see fuel type, whether it's OD or alpha remoter, aspiration is 2 or 4, number of doors, whether sedan or kickback or convertible, and body style RWD or FWT, and drive wheels, whether it's front or rear, engine location, which is numeric, which percent, 88.6, 99.8, based on the car, and wheelbase, length, width, height, and curb, width. And you can see here engine type, which are the engine type of the car is 4, 6, or 5, and so on. And number of cylinders, be 100 something or less than 100. Engine size in BFI or other. Fuel system, 3 point something or 2 point something, and bore is 2 point something or 3 point something. Stroke and compression ratio, horsepower is the power of the engine, peak and city, highway, price. This for we create this for observation, as we will explain later. For this, we prefer correlation matrix on choosing variables, that we will choose the sum variables, because of course we will not need for all the variables in our data that we choose previously. We need some variables only, and these variables we see the correlation between variables to create other columns to predict the price of the car. The objective, determine which variable have high correlation with each other. Doing this curve helps us to eliminate one of them in the final model, since this curve affect the performance due to collinear problem. And we can see the model development. We apply the multiple linear regression, and when we apply the multiple linear regression in our data, we calculate the R square, and then we will apply another algorithm, multiple linear regression. This linear regression, multiple linear regression, and polynomial. After every algorithm, we have to calculate R square, because at the end we will compare between all of these models: linear regression, multiple linear regression, and polynomial multiple regression. And we will see we will compare between R square, and we will see the accuracy, which model is better than other, and we can choose the model then. Uh, we can see the model for the first step for building the model, the polynomial. We will load the data set, and then we will sublet the data set. We will create the polynomial variables for some variables, because we will really need for some columns, some variables, to create another columns in order to predict proper price for the customer. And then we will try different degrees, and then we will combine the R square for single linear regression, multiple linear regression, polynomial multiple linear regression, and then we will stop when there is no change in R square. When the last R square equal the previous, we will stop there, and we will see the model and the accuracy of our model, and then we will choose the best model, and we will build our project based on this model. And my friends will explain more in this. We will explain in depth by using coding, and how can we create the columns, how can we find the accuracy, and so on. I finish my part. Assalamu alaikum wa rahmatullahi wa barakatuh.
Assalamu alaikum warahmatullahi wabarakatuh. Respected lecturer, I am Hossein Mohammad Sharjil, and my metric number is 1623499. So today I will be presenting about our group project, which is the titled as car price prediction. So let's see what is our project all about. So first off, we see into the introduction that this model or this program made developed by us, it can be used by any customer for one's own selling their own car. And also applications like Moda or eBay, they can use our model as an API into their website for uh, selling, to set prices for cars within reasonable range. And also, in addition to identifying some product is a scam, or is it like it has a high price or low price, or what it should actually be within the customer budget range. So next we look into the objectives. We pinpointed like 6 objectives, which are very basic, and but also very important for any uh, like any data science process or like any machine learning process. So it's really important. First, we are to acquire the data, and we are to clean the data set, and then we have to select the very best features for our model with the highest effect on the price. Then obviously we are to visualize the certain amount of data, and also we are to do data analysis using machine learning and machine and different types of machine learning algorithm, like comparing between linear regression, multiple regression, and polynomial multiple regression. Next, it's the to understand and build polynomial multiple regression algorithm. Last but not the least, to evaluate and enhance our model. So next we get into the expected output. So from our model, we're expecting that it will be able to predict the car prices, as the title of our project suggests, that it's used car price prediction, with an accuracy of at least 0.65 or 65%. If not, we are going to go back to refining or modifying our dataset or analysis approach to get much more better results. So this part is the most important and crucial part, for like working on with any kind of data set. It's the data pre-processing. So from my part, I have done some data pre-processings, so I will just go through one by one to mention some of them. First, we are to create a list of all the header names for each column as shown here in the code segment. Then we are to print out to see what is the output. Then we are to set the header name for the columns, as we can see through this chunk of code, and here it's the output of the code. And then the comes for replacing values, like there are certain, as from the results we will about to see that there are some values that contain the missing values, like the question marks or something like that. These are missing values which can like jeopardize our objective in doing a much more better analysis. So what we are to do, we are to identify them, we are to identify the missing values and then convert them to none. So that's what is done here, as you can see here in the chunk of code that we previously it was here, as you can see in the normalized losses, as you can see here there were so many question marks or missing values, and now we replace them with NA values now. Next is finding the missing values. As we have all in the previous step, we have converted all the question marks to the more familiar NA, so that we can easily find the missing values and we can arrange them or handle them accordingly. So this through by running through this code, we can easily find the missing values in our data set. And also we can also find the missing values in each column for any specific column or something like that, or in every column we can find. So that's what we did here. True means the value is missing, while the false, the value is present, which is quite normal. And then we count the number of missing values in each column. Then this is the output, like the snip of the output. Then we move on to how to deal with these missing values. There are certain approaches, as you can see in the screen, like we have drop data, drop the whole row, drop the whole column, or by replacing data. In replacing data, there are certain aspects like replace it by mean, then replace it by frequency, replace it or it based on other functions as well. So uh, we will see that as in our data set, as we really don't have not at all, like most of the columns don't have like very less data that we cannot ignore. So dropping the whole row or dropping the whole column will not serve our purpose, but what will help is by replacing the data, just like by replacing by mean or by frequency and so on. So as you can see, we took the normalized losses column, and what we did here is that we found out the mean of the column normalized losses, and with that mean we replaced the missing values or the NA values in of the normalized column with the mean. That's what this approach is all about, replacing data by replacing it by mean. That's what we did in here for normalized losses. Further, we can also we did the same thing for the bore column, like we found out the mean first, and then after finding out the mean, we replaced the missing values of the bore column with the mean. Then also the similar thing has been done for the stroke column, the horsepower column, and the peak RPM column has been done by achieving this strategy as mentioned here, replacing data or replacing it by mean. Lastly, I would like to add one point that for the price column, certain aspects has been done which will be later presented. So we have to, because as we are dealing with the used car price prediction, so price is a very important factor in our data set. So we have to bear in mind in dealing with that column and being extra careful. So we saw that these are very basic but yet very important for any data set to establish or to go further into the uh, to be more to get more in-depth analysis over any data is to do the data pre-processing properly from the beginning. Otherwise we will not be able to achieve our goals properly. So that's all for me now. Thank you for your attention and thank you for listening. uh, I will end my presentation here. Assalamu alaikum wa rahmatullahi wa barakatuh.
Okay, Assalamu alaikum wa rahmatullah. My name is Abubakar Yaqub. We'll be finishing the data pre-processing. So after we converted some of the missing values here to their respective means, now we do something similar to num of rows column. Instead of doing a mean, we take the value that's most common, which is 4, and we set the row within A to 4. Now we drop the rows within A price. Because the price is the thing we're trying to predict, we cannot afford to have it empty. Now we reset the index because we have dropped 4 rows. Now if we take a look at our data set, we can see that the columns we just worked on are of type number. We need them to be of type factor because that will help us in the model development later. So we set the right column type here. We'll convert to column later. After that, the next step in data pre-processing is we can see that the fuel consumption column are represented by miles per gallon in it. Assume you are developing an application in a country that accepts the fuel with liter per 100 kilometers standard. You will need to apply that transformation. Now we transform the two columns, city MPG and highway MPG, to liters per 100 kilometers. The formula is we divide that by 235. We divide 235 by that. After that, our next step is normalization. Some of the values are very high and that's not very helpful. So we need to get it between 0 and 1. The 3 columns we're going to do this to are length, width, and height. Now if we check the height, all the values are at least less than 1. Now we do some simple graphing. You can observe here in the histogram of horsepower, we have more than 50 something values, more than 50 something in the total count. So we need to scale it down because when we are doing the model development later, we need the classes to be more defined. So what we're going to do is we're going to divide all this and try to scale them down into 4 values here. Now these 4 values, we're going to give them names: low, medium, and high. Finally, we apply the cut function to the original horsepower column, and with these values, we will get a new column called horsepower pint. You can see from the previous values, we have 153 low, 43 medium, and 5 high. Now if we see our new graph, we have only 3 simple classes, which is easy. Now we can do the same graph but with the actual values instead of the names of the classes. After normalization, cleaning up and all that, now we have one final step, which is creating dummy variables. Dummy variables are basically for columns that are not really helpful in their current state. For example, this fuel type column has 2 values, either gas or diesel. Gas or diesel are not very helpful for a learning algorithm, so we change it to 0 or 1 according to each car. To do that, the process of doing that and the variable created are called dummy variables. So we do this to all the data frame here, and if diesel is 0, means the car is running on gas. If diesel is 1, means the car is running on diesel and gas will be 0. Now we append those new dummy variables to our original data frame and delete the original fuel type. We do the same for the aspiration column, which has 2 values, STD and turbo. Same thing. And after that, if we take a look at our data set, we can see that We don't have any more missing values. All the number of doors have values here. City MPG, highway MPG, we also have for other cities that don't use those measurements. We don't have any NA values in price. We have scaled down the horse column to horsepower bins. We have scaled down the fuel type and aspiration to these 4 values. And that's all from me. Thank you.
Data exploratory analysis and visualization. Okay, in this section, we have implemented 2 types of variable analysis techniques. The first type is numeric variable analysis, and then the second type is categorical variable analysis. So we start this data exploratory analysis and visualization by checking correlation. Correlation of what? Correlation between variable and response. And only integer variables are selected, and these are the 16 variables that we have chosen for this report. The reason why we only choose integer variable is because correlation can only be seen clearly with integer values. Then we perform correlation matrix on the chosen variables, correlation between each variable and the response and with other variables. The objective of doing this is to determine which variable have high correlation with each other. Therefore, by doing this, it can eliminate one of them in the final model, since this can affect the performance due to collinearity problem. So this is the R code. So this is the visualized data in a table form. We have also used R code to visualize the results. Therefore, this enables us to see obvious correlation between some variables and response, and even between the variables with each other. So this is the output. Okay. Numeric variable analysis. In this section, we have done an extensive study that includes analyzing each variable with the response individually and graph the relationship. So this is the first graph of numeric variable analysis. So we can see that the relationship between engine size and price seems to be positively strong. In this graph, we can see that the relationship between price and highway.mpg seems to be negatively strong. Whereas for this graph, we can see that there is no linear relationship between peak.rpm and price. Okay, this is the second type of variable analysis technique, categorical variable analysis. So in this section, we have done an extensive study that includes analyzing each variable with the response individual and graph the relationship. Okay, this is the first type of categorical variable analysis graph. From the following, we can see that the body types have so much overlaps with price, thus it will not be good to choose body style as a predictor. The second graph, it shows that the distribution over the price here are very distinct, so engine.location is very good predictor. Here we see that the distribution of price between the different drive wheels category differs. As such, drive wheels could potentially be a predictor of price. Okay, before we proceed to the next step of machine learning, which is model development, we have listed the important variables that we will be using in the model development. So in terms of categorical variables, we have chosen drive wheels, and whereas for continuous numeric variables, we have chosen these variables. That's all from me. Thank you.
Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Al-Abusi Jafar with matric number 1713599. I'm going to talk about the part of in our project is car price prediction. I'm going to talk about the part of modeling. I'll discuss the full part. So the introduction, we've already seen that we want to predict the price of a car, and this can be beneficial for a single user or for an organization like Moda and Lazada. They can use our model as an API in their application. The objectives are the same as almost the same as the methodology: acquiring the data, selecting best features, visualizing the data, and do the data analysis. And then the most importantly, and which is the core of our project, is to understand and build a polynomial multiple regression algorithm and evaluate and enhance the model throughout our steps. We are going to start from single linear regression model, going to multiple linear regression model, ending up with the polynomial multiple regression model. The expected output, we aimed at the beginning of our project to achieve the accuracy of 0.65 or 65% of the predictions to be true. And alhamdulillah, after we worked in the project, we achieved something like 80 to 90. We'll see later how we achieved this. So this is the model development. I guess it is already explained by my friends how we are going to develop the model. We are going to start from single linear regression, calculating the statistics, which is R squared, then multiple linear, then polynomial linear. And the R square we are calculating here just to compare between the models and how we are going to enhance them. Now the core idea, which is the polynomial model, it is the same idea. The algorithm or the general steps are the same as the multiple regression, but we are going to transform some of the predictors to a certain degree. For example, I will start with the degree 2. I will transform one variable to degree 2, then 2 and 3, then 2 and 3 and 4, and compare these models and see the R statistics. And we are going to stop when the R statistics has no increment or no enhancement in the model. So just stick to the least degree that gives you the best R square. So we started with the single linear regression, which is the most naive one. And of course, the equation, you can see the equation for the slope and intercept is easy. So X is the predictor and Y is the response. We are creating one list with the intercept and the slope. These are the returned values. I'm going to return these values. I'm going to calculate the slope first. Then from the slope, I'm going to calculate the intercept. Then these are the values. I calculated this for the engine size versus the price as the response. So the engine size is the predictor, and here is the intercept, and here is the slope. And then I calculated the R squared values. The R squared values are some statistics you are doing on the model, on your model. It's between 0 and 1. So how to translate them, how to interpret them? The higher the R squared is, the better, because that means, for example, how to interpret this value, 0. Let's say 50. It means this model can explain 50% of the variance in the response, can predict like 50% of the response accurately. So this is for single linear regression, and this is multiple linear regression here. And you can see the algorithm is like almost the same for the polynomial, as we will see later. So I'm just selecting the features for the multiple. I'm going to use more than one predictor. So this one is going to be the matrix, because when I use multiple regressions, I need to use matrices because it's easier to produce the coefficients. Okay, the slope and the intercept and all of these things. So the prediction matrix here will have the predictors that I'm going to use to predict my response, only the predictors. Then I will add one column. This column will have all the values or the observations as one, because this one is for the intercept. So when I multiply with the Y, I'm going to have the intercept at the beginning. Then I'm going to convert this new data frame to matrix. Then I'm going to do this equation. This equation is going to produce my coefficients and my intercept. The inverse of the transpose of the matrix multiplied by the matrix of itself. I'll take the inverse of this multiplication, then I'll multiply it by the transpose of the matrix, then I'll multiply it by the response. I will get my coefficients. So here is my predicted price, not the actual price. So the predicted price can be, this is the intercept, first coefficient for the first predictor, which is horsepower, then cube weight, and so on. So I can see here the R statistic, or the R squared, is much better than the previous one. So it is here, it is like 81%. These are the residual plots. I'm plotting these to show you the problem of the non-linearity and how we improve the model. So this is the single linear regression residual model. So I'm plotting the residuals against the predictor. So right here you can see the values are far from zero. It means I'm having so much residuals, so much difference between the predicted and the actual values. While here in the multiple linear regression, I can see the values are near to zero, more focused on zero. It means the residuals are less now. But the thing I want to handle here is the non-linearity of my model. You can see the model is producing this shape of residual. It is like U-shape, and here it is more, like you can see, it is more obvious that the non-linearity. You can see as I'm going up, these values are going so much up. Right here I'm using the polynomial model. Okay, so this is the polynomial model. My algorithm here is going to take the most correlated variable with the response, which is highway MPG. We already calculated the correlation, and we are going to increase it to the degree of 2 and 3, and we are going to add these we are going to consider them as new variables. It is just the same as this variable, but we did these transformation and we add them to the data set as new variables. And then we have this as for the intercept, this the one column, and we have done the same algorithm, the same equation, and we produce these values. So you can see here now I have highway MPG, then highway to the power of the 2, and highway to the power of 3, and then you can see the R squared is now better. It is 82. Okay, now all of this, the R statistics or the R squared is only for the data set itself, for the training data set. Now I want to test my model, the polynomial model. I want to test for a testing data set that I've never used before. Okay, so I'm going to split the data set. This is the training data set. It is 160 rows. Okay, I'm going to build the model upon this data set, and I have some values. They are near to the training one that I just found before. Then I'm going to make this testing data set. I'm going to test my model on them, and I tested the model, and the result was amazing. I am able to track 91% or 92% of the response using my model, and it is even unseen data. It means my model is not suffering from any under or overfitting problem. So this is the best model we can come up with for this period of time, and for using this knowledge that we have. Thanks for listening. I appreciate your time. Thank you so much, and special thank for the teacher, because you hold us all this time together. Alhamdulillah, and thank you so much. We gained this knowledge because of you after the grace of Allah. Thank you so much.